Good morning, everyone. So first of all, let me welcome everyone to Edinburgh. Hopefully you'll get a bit of a chance to look around the city before you head back to your parts of the country. For those of you not aware, Corero is a DDoS network security company. We build a variety of solutions for service providers, hosting providers. And what may also not be known is that our R&D base is actually here in Edinburgh. So our offices are within sight of that lovely castle there. In terms of what's been happening on the DDoS landscape, we often show this kind of picture through the sessions. And the message here is that the big event of 2018 so far has been Memcached. That was the biggest recorded DDoS attack that has yet occurred over the period that's been monitored at 1.7 terabits per second. And that attack is still happening today, despite the fact that most of the Memcached servers have now been secured from that vector. The other standout event in recent years was the Mirai botnet. And for those of you not aware of the details there, the target, if you like, was video surveillance cameras. And to me, that is indicative of the weakness of the Internet of Things class of devices. And what we see with those devices, they're cheap to deploy. They're thrown on the Internet often with default passwords or very weak forms of security. Their engineering themselves is extremely weak, and they're never ever patched. So this growing set of devices is connecting to the Internet, which when they get compromised, is simply going to mean they can launch meaningful attacks in very, very large numbers and be thrown away again to find another set to launch an attack in the future. So the Internet of Things is a particular concern to us as a DDoS specialist because of that ability to launch even modest attacks from an individual device but gain a very large set of them. So the attacks themselves were not different from anything we see. They were a traditional multi-vector DDoS attack, but just the sheer scale and ability to harvest the devices was what was interesting there. So you see the general trend of this graph here. The sizes of the attacks are growing, and the frequency of the attacks are growing, as you see from the bubbles in the bottom right. But that's not really the true story. These are the stories that make the headlines when you read the news or hear about things in conferences. It's the big terabit attacks that everyone's excited by. The far bigger problem that we see is the small, frequent subsaturation attacks. And these statistics here are representative across Corero's customer base of what really happens with DDoS attacks. So the messages here are, first of all, the rate of attack, the number of attacks is continuing to grow. We've seen a 40% increase in attacks over the last 12 months alone. So the DDoS problem is not going away, it's getting worse. The second statistic of 7 is the number of attacks on average per customer per day. For reference, last year that was 6. So the number of attacks that each customer is getting when they're a victim of DDoS is going up. But the story on the right is the rate of attack, the speed of the attack, if you like, and the duration of the attack. And these are the things that don't make the news stories. First of all, 82% of them are short, 10 minutes or less. And for many customers, the damage is done often within the first minute, let alone across a 10-minute period. So by the time some solutions will react to that, the damage is well past and we're in a recovery posture. The second is the capacity of the attacks. 1.7 terabits is extreme. What we see is 94% of attacks are 5 gigabits per second or less, often well sub-saturation of an internet link. And these are the attacks which we see most companies or most providers would be worried about or want to do something about. So what do we see happening beyond that? There are still new vectors occurring. Memcached is one of the new vectors of the last 12 months. And there are going to be more of those things as we end up with new applications. Security is a constant problem. there's going to be another memcached of some other application size. But the second trend is the growing risk that these represent. And it's no longer just about continuity of business. It can affect the top line, or it can cause regulatory risk to a business. UK infrastructure has been in the news recently, concerns about geopolitical situations, or the risk of attacks on power stations was mentioned on the news only this week. And in our Freedom of Information study that we did, 70% of the critical infrastructure of the UK could be at risk of fines because of lack of preparedness for cyber-type attacks of this nature. And that's coming about because of the new EU NIST directives, which were launched in the summer this year. In terms of the effect on a business's top line, it's also significant. If your customer base sees a loss of service and you're maybe an online presence, if we lose the service, not only is it going to affect that period of business, but your customers may well go elsewhere. And you will lose the trust of those vendors from the loss of service. And last but not least, there's a meaningful risk of further security risk, which is data breach. And a lot of the survey results here showed that the IT professionals are concerned about the use of DDoS as a method to infiltrate data, perhaps through distraction techniques or things of that nature. So that's the sort of macro trend of what's happening in the DDoS space right now. So enough about the vendor stuff. I'm actually an engineer. So I run Corero's R&D group here in Edinburgh. And what I wanted to focus most of the talk on here was some work we've been doing in high-performance packet processing with a nod towards network function virtualization and SDN. So first of all, we thought it might be interesting to ask you guys a couple of questions back. So first, a quick show of hands would be, how many people here are using or deploying 100 gig links? Let's start with researching it or are actively deploying these things. So it looks like maybe about a third or a quarter of the room. Great. How about SDN next? Software-defined networking? A bit less than that, thank you. And network function virtualization, trying to use white box servers to do network functions? Less again. All right, thank you. And if you are using SDN or NFV, what's your interest in hypervisors? Let's try KVM first, is the one I'm expecting everyone to be interested in. Yep, a few of those. Anyone with VMware? Nope. Okay. And how about public cloud? Are you all using public cloud solutions for security? Okay, good, thank you. Well, the interest in that is we've noted a couple of trends happening in the industry, and we're doing some research work ourselves to figure out what this meant for DDoS protection. So first of all, we've seen a clear move to the upscale of internet links now. We're moving through 10 gig, the leader companies, the bigger companies are now into 100 gig links, multiple 100 gig links. The goal there for us as a line rate company is to offer the same experience there at 100 gig that we offer at 10. The next issue we've seen is the general interest of moving off of proprietary expensive hardware onto using commodity Intel-based servers where you can maybe spin them up, spin them down as your workload requires. And lastly is the goal of making everything programmable. So SDN represents that in terms of traffic flow management and turning workloads on and off and steering traffic through certain network service chains. So we asked ourselves how practical it was to build out on this in some ways that mattered to our company. So first of all, could we develop a line rate 100 gig DDoS appliance on commodity hardware? So taking an Intel stock server, shall we say, and figuring out if we could meet our attribute loads at 100 gig. The second was, could we do that in a way that did not reduce our portability? Corero is a software company. It's not a hardware company. And we can't afford to build lots of things multiple different ways. So we were looking for one common paradigm that would allow us to meet the target. And lastly, if we used a 10 gig line rate, if we targeted a 10 gig line rate solution in a virtual machine, not on a bare metal type of server, could we get that line rate solution through current hypervisors? So this is the story that we've got to so far on that journey. So the attributes that we have as our solution that are important to this are shown here. Accuracy, there's no prizes if you block the wrong traffic. You're going to do damage to someone's network. Real time, if it's too slow to react, you don't actually block the DDoS attack because these attacks are short, as we saw earlier. You must not do any harm to the network. So when there's no attack, our goal is to be like a wire. And it doesn't matter whether these packets are small or large. We're going to let them through and not do any damage to the network. And lastly, we needed to maintain our ability to visualize the network and do forensic analysis within the network. So that really meant that our solution had to work the same as it does at 10 gig. And if we were to break those paradigms, in essence, we're as bad as the attack. If we block the wrong traffic when there's not actually a DDoS attack going, then your network's just as affected as if the attacker was doing it. So the technical challenges that were faced from doing that were finding that common software architecture capable of delivering both high performance and portability. How to avoid the virtual machine hypervisor overheads, which are famous for taking multi-gig links down to hundreds of megabits per second or slower. And lastly, how could we get to 100 gig line rate in hardware? So starting with the last one, we did some analysis of commodity Intel hardware with off-the-shelf networking. In this case, this is commercial network interface cards, 100 gig NICs that you can buy publicly. We're not going to note them as to who the vendors are. But the message on this was when we're using DPDK, which we'll talk about in a minute, none of these NICs are capable of delivering line rate. In fact, some of them can't deliver line rate regardless of packet size. They were sitting at 80-odd% line rate, 90% line rate with the worst that we saw in green. And those that did achieve line rate, if you're not up at 500 byte packets, they're going to be dropping. And so the message to us was that there was no way with those NICs that we could deliver the same class of performance at 10 gig, which is focused on 64 byte packets, that we do at 100 gig with this technologies. So we had to look elsewhere. And there's a range of solutions and specialist hardware, FPGAs, NICs, from specialist vendors with FPGA assists, networking switch silicon, all sorts of things. We're not going to tell you quite what we chose, but ultimately we concluded to solve our problem, we had to use something of that class to get the attributes we required for small packet sizes. So next the question was, well, what about software? And we rapidly adopted the Intel DPDK type methodology, data plane development kit, not only because we had people who'd done it before, which was obviously a big benefit for us, but because it's a proven engine for high-performance packet processing, avoiding the overhead of the Linux stack. So if you're not familiar with DPDK, the goal there is shown in the bottom right there, where the network controller is passed through the Linux stack, bypassing the drivers, bypassing the kernel, to a user space world where the application runs, in our case, that one with the red square in it. So Linux doesn't see the packets, it doesn't see the interfaces, and the application works directly to the hardware. And this is a broad and effective ecosystem. These are all representative of functions you can pick and choose off the DPDK infrastructure. They include hardware solutions, particular chipsets, accelerators like crypto, quality of service, etc. So there's a rich ecosystem for these. And for Corero, it meant that we could adopt an architecture a bit like this. On the left is a hardware-based appliance, a dedicated system. So there's no hypervisor in that environment. We're connecting straight to the network interface cards. And we're able to build a small, thin library called the platform in green here, which abstracts the rest of our software from the details of that hardware platform. And on the right, we can achieve a somewhat similar effect, but with a hypervisor. In this case, we saw the best performance on KVM, but we also got VMware to line rate as well at 10 gig. And there we were able to use tricks like PCI pass-through in order to give the fastest possible cut-through I/O to the hypervisor. And so this essentially meant that we were able to meet most of our goals of commonality. So the conclusions of where we've got to so far is, yes, it is possible to build a 100 gig line rate on Intel, but you're going to need some specialist network hardware if you care about small packets. Also, you can't just keep throwing cores at things. You see a lot of contention start, you sort of hit a bump, a maximum amount of performance, at which case packet contention starts to be a problem, and we certainly saw that effect. You also need to design for this stuff. We were very concerned about our workload. It's all very well forwarding packets at line rate, but we were trying to inspect them, which meant looking at every single one of them. And you must design with that in mind. Otherwise, you'll have all sorts of strange loss effects. Can you build an NFV solution that can do DDoS at 10 gig? Yes, you can. And in fact, we would have that available to you today. Can you make your code software portable? Yes. With DPDK, 95% of Corero's code is unchanged, whether it's working on a hardware box or on a hypervisor. And lastly, getting close to line rate's easy, but the trick is getting all the way to line rate. When you get close to line rate, you start seeing the odd packet loss. And if what your goal is to try and be like the wire and do no harm to the network, which was our target, there's a lot of work involved in getting that last few percent and reliability over an extended period. So that's where we are today, and hopefully we'll do some follow-on talks at another session. So, any questions?
If there are any questions, of course, Neil has one, but we'll start with James over here.
James from Chisk. Two questions, actually. Wouldn't it have been easier for your appliance to use the same hypervisor, so you just actually literally ported the hypervisor on the appliance, or whether it's in a network environment? And secondly, which Intel cards did you use?
Well, I'm not going to answer the second one, I'm afraid. But suffice it to say, it's not a regularly available network card that you could buy on the open market. So some specialist hardware was developed for that. To the first question, you're absolutely right, and that's where we wanted to start. But the reality of our problem was getting to 100 gig line rate. We couldn't afford the overhead. So although the cut-through I/O and PCI pass-through and things like that will eradicate a lot of the overhead, it's just not quite enough. And especially coupled with the special hardware we were using, we had to go bare metal in that position. Yep.
There's a question from Neil over here.
So I wonder why you did it.
Sorry?
Why did you do that?
Do what?
What you've done.
Why would we do that?
Well, because right now you've got a hardware appliance and it works and life is good. Now you've got a different type of hardware appliance that by your own definition has special hardware in it.
Yep.
So what's the difference?
Well, the difference is especially in portability. So today, if you come to our website, we can sell you all of these things. We've got a 100 gig line rate box in 1U. We've got software NFV functions, and so we're trying to be prepared for all those market opportunities.
But do I not need the special hardware?
No, the NFV solution does not. It runs on a commodity Dell server or whatever you like.
Okay, so you've got a solution. Sorry, I misunderstood that. You've got a solution that's just like not line rate.
Yes, I'm sorry, I didn't obviously say that well at the end. 10 gig line rate we can do in software, in an NFV, on VMware or KVM with no special hardware at all. You can just take an Intel standard NIC or whatever. 100 gig is a different matter. That's really pushing the envelope. And there it is a dedicated appliance, but it is Intel-based, and we share 95% of the code in that environment with just a small amount of specialist hardware. And over time, hopefully, we'll be able to remove that as well.
And which leads me on to my next question. How have you so your business model of shipping boxes is quite different to a business model of shipping licenses. How does that work? What have you had to think about in changing that?
Well, we're still on that journey, I think it would be fair to say. Corero is a box shipper in predominant sense. But in software terms, it's about whether it's perpetual licenses, time-limited licenses, capacity licenses, making sure you don't damage the network with silly things like licenses expiring and cutting networks off on people. There's a lot of complexity in the sort of deployment manageability, and that's before you get to the sort of orchestration levels of fitting in with switch-on, switch-off managers.
Just remember your audience is service providers. We're not very good with complexity. It's just a free feedback for your product development team. Thank you. It was a good presentation.
You're welcome.
Are there any last questions for Julian? No? In which case, I'd like to thank Julian for a fascinating presentation.
Thank you.